Hello all, and welcome to the Geometry Assessment Solutions. So if you're intending to reassess, or if you did not take the assessment last week and complete it on time, you need to go through the Assessment Solutions video in order to do that. This is Mr. Crowther speaking. So this is regarding the Option 1 assessment, which was the Google form assessment. Option 2 was the finding things at home and answering questions and inserting pictures. That's unique to everybody who did that. So there can't be a solutions video on that, but this will definitely help you with the trigonometry involved in option 2. So without further ado, let's move on to our first competency, which was apply and evaluate. There was 3 questions regarding it. And the first question was solve for A, answer in simplified radical form. So I have a right triangle. I have no angles involved, but I'm just looking for the side. So I'm going to use the Pythagorean theorem. And that says that side A squared, sorry about that. Side A squared plus AC, which is 12, will equal the hypotenuse squared. So now I'm just doing the math out. 12 squared is 144. 20 squared is 400. I'll subtract 144 from both sides. I get 256. So to solve for A, I've got to take the square root of both sides. And A equals 16. So it was not in radical form, so 16 is a good answer. There are no units. So that's what you should have had for number 1. Moving on to number 2. Find the missing side. Make sure you round to the nearest tenth and show the ratio you used. So given the angle of 46 degrees, the sides I'm working with are the opposite and the hypotenuse. So if I refer back to my fantastic SOHCAHTOA anagram, opposite and hypotenuse, go with S, which is sine. So my ratio is going to be the sine of 46 equals the opposite, which is 8, over the hypotenuse, which is the unknown x. So to solve this, I have to multiply both sides by x. This will eliminate the x in the denominator. To get x by itself, I have to divide both sides by the sine of 46. So I have 8 divided by the sine of 46, which to the nearest tenth is 11.1. So again, the key points are this ratio right here, sine of 46 equals 8 over x. And then your solution rounded to the nearest tenth, 11.1. The third apply and evaluate was to find the missing angle. Again, round to the nearest tenth and show the ratio you used. So because you have all 3 sides, you could have used either of the ratios, sine, cosine, or tangent. So going back to that SOHCAHTOA, the sine of the unknown angle, we'll call it x. So this is my unknown angle. This is going to be my opposite side. This is going to be my adjacent, which means this is my hypotenuse. So the sine is opposite over adjacent. So 60, or opposite over hypotenuse, I apologize. 68 over 85. If you were to use cosine, you would use the adjacent 51 over the hypotenuse, which is 85. And the tangent It's going to be opposite over adjacent, so 68 over 51. So to find the missing angle, I need to do inverse trig. So I'm going to use inverse sine. Inverse cosine. And again, you didn't have to do all three of these. You just had to choose one and make sure you had the correct ratio. Or inverse tangent. And it didn't matter which one of these three ratios you used. If you had the ratios correct, you would get the same measure of the angle, which to the nearest tenth was 53.1 degrees. So those were the three questions that made up your apply and evaluate competency. The next competency was distinguish. So given the triangle PQR, which is the one shown on the screen, find the sine of P, cosine of P, and the tangent of P. So the sine of P, cosine of P, tangent of P. As well as the sine of R, cosine of R, and tangent of R. Write all six ratios as fractions and clearly state which ratio goes with what. So all your answers should have been in fractional form. So if I'm going off reference angle P, 12 is going to be my opposite, 5 is going to be my adjacent, and 13 is going to be my hypotenuse. So SOHCAHTOA, sine equals the opposite over the hypotenuse. So the fraction 12/13. Cosine is the adjacent over the hypotenuse. So 5/13. And tangent is opposite over adjacent. So 12/5. If I'm using reference angle R, the 5 is now my opposite side, and the 12 is now my adjacent side. So this changes up my ratios. Sine is now 5 over 13. Cosine is now 12 over 13. And tangent is now 5 over 12. So as we go into number 5, it asks you to recognize if any of the ratios were the same. Well, if I've done all 6 out correctly, I can see that the cosine of P and the sine of R are the same, and the sine of P and the cosine of R are the same. The tangents are reciprocals of each other, but they are not the same. So that leads us right into 5. Are any of the ratios the same? Yep. It said the sine of P and the cosine of R, and the sine of R and the cosine of P. If so, explain why. And some of you just missed the explanation on this one. So this is a good explanation, but if you are along these lines, I'm sure you got credit for it. Based upon the reference angle, that being P or R, the sides referred to as opposite and adjacent switch places, but the hypotenuse for both stays the same. So just like we showed in the diagram here, when we were at angle R, side PQ was opposite, but when we were at angle P, side PQ was the adjacent. So that's why the ratios are the same, is because the opposite and adjacent terms switch places in regards to the angle that they are talking about. Number 6, throw back to similarity and determining why the sine of C is equal to the sine of C prime. The simplest and basic answer was the fact that the similarity definition states that all angles that correspond in both figures are congruent. So in this figure, I have the two right angles, B and B prime. They are the same, 90 degrees. Angle A is a shared angle, so the third angle, C and C prime, must be the same. So if I'm taking the sine of C and the sine of C prime, and they are the same angle measure, they are going to be equal. And again, that comes from the fact that they are similar triangles as stated in the problem. So if you're doing this for reassessment, this is the verification word, mackerel. Mackerel is your verification word to take the reassessment. Moving on to our last problem, the modeling, create, and build. So I have two observers standing 100 feet from the base of the building. So if observer 1 is over here, this is 100 feet. And observer 2 is over here, this is 100 feet. The angle of elevation to the top is 62 degrees, and to the top of the tower is 68 degrees. Find the height of the tower. So I'm just looking for the height of this tower right here. So in this triangle, I'm going to refer to this side as X, and in this triangle, I'm going to refer to this side as Y. So based on this angle of elevation here, I have the opposite and adjacent sides, which means I'm using my tangent ratio. Opposite is unknown, adjacent is 100. So multiplying both sides by 100 will give me X. And 100 times the tangent of 68 is 247.5. So with the triangle on the right, again, I have tangent, except my angle is 62 degrees this time. My opposite side is Y, my adjacent side is 100. So again, I'm going to multiply both sides by 100. And 100 times the tangent of 62 is 188.1. So I know the height of the building is 188.1. The height of the building and tower is 247.5. So to find the height of just the tower, I must subtract the height of the building from the total height. And when I do that, I get the height of the tower to be 59.4 feet. To the nearest tenth. So hopefully this helped you out in your solutions. If you still need more help, make sure you touch base with your teacher. We want to make sure that you are on point as we head into the final stretch here. Thank you for watching. Hope you guys are all safe and well.